Hello, class. So I'm going to continue with the chapter 3. And this section, I'm just going to work more examples on the 2D force system or coplanar force system. So in the previous video recording, I said if a particle is in equilibrium, then the sum of forces vectorially is 0. But if the particle is in 2D, is in a plane, then the sum, we can just say the sum of forces in the x direction is 0. Sum of forces in the y direction is 0. That's if you are looking at the particle in the xy plane. If the particle is in the xy plane, maybe subjected to some kind of force. And the forces are, of course, coplanar and then cocurrent. So we're going to use this one. I solved these two problems last time. The first one is just on 1D. So on 1D, it's just the sum of forces in the x or whatever the axis is here. If the axis is here is m, sum of forces in the m is 0. So you add the two, you add whatever force is there equal to 0. And then if there's unknown, you solve it. And for 1D, you can have a maximum of 1 unknown. For a 2D, you can have a maximum of 2 unknowns. And then you solve it. Because you have 2 equations you can apply here, you have only 1 equation. So I will solve in these 2 problems here, it's as if the free body diagram have been drawn. But in my next example, we have to draw the free body diagram before we solve. So I'll solve 2 or 3 problems and then I'll end the recording. So if you look at this problem here, we have 2 cables, one here, one here. This is some kind of a ring. And then the cable that is holding the weight. Okay, so as I told you, yeah, they wanted to determine the tension or the force in the cable CB and CA. Okay, at this position. So the whole system is in equilibrium. The whole system is in equilibrium. Let's determine the force here. Okay, so we're going to use a concept of resolving, and then we balance the forces to solve it. We are taking the mass of this cylinder to be 10 kilogram, and we are taking at this position that is in equilibrium. Theta is 60 degrees. Okay, so I will switch. There's a comment here that I'll talk about it later on. I'll switch the OneNote and then work this example. So the first thing is you draw a free body diagram. Please, you have to draw a free body diagram. Okay, you have to draw a free body diagram. So you make a point here, and then you show the forces. So there's a force here, which, of course, you have to cut the rope. Okay, I don't know how you want to call it, but let me call it like tension B. Okay, you can call it tension in BC or tension CB, or you can call it force B or force BC, whatever you want to call it. And this angle is 60 degrees. The tension here is the same as the weight, so you can represent the weight directly. And that is what is up here. Or you could have drawn another free body diagram, but the tension here is 10 times G, or 10 times G is 10 times 9.81. So 10 times, that would 98.1 Newton. So you could put that there, but I would like to keep it this way. And on this side, let me draw this again. On this side, this is like 30 degrees. So I'm going to call it TA. And the angle here is 30 degrees. Okay, and that point is C. So that's your free body diagram. And that is very important. You draw a free border. This angle, of course, is 90 degrees. Yeah, this is 90 degrees. Now, you could have also drawn I'm using this, you could have also drawn the free body diagram on this side. This is FB, what, TB, TA, and then you can see this is like so let me see, this is D or TD. And then this here is the same as, then you can put a weight here, 10G. So later on you say 10G, TD is 10G. Okay, but because we know that, that's why I'm putting this one. And of course, this one is in Newtons. It's in Newtons. Okay, so let me apply the equation of equilibrium. So the first one is, you always watch, you can do the summation of forces. So this is like, if this is like my X and that is my Y. So you can do the X first or Y. In this case, we have two unknowns. So if you write equation in this direction, we have a TA, TB. If you write equation this direction, you have a TA. So it doesn't matter. So let me do summation of forces in the X first, equal to 0. And I'll have those pulling this side equal to those pulling. So I'm going to get TA cosine 30 is equal to TB cosine 60. The angle are all to the horizontal. You can leave it this way and work in the cosines. Sorry, this angle is 30 degrees. This is 60, yeah. Okay, so you can leave it this way and work in the cosine 30 and cosine 60. This way, but if like you can simplify it in decimal or in exact form, I'm going to work in the exact form. This part is not necessarily among. So we have TA cosine 30, I finish √3 over 2. And then cosine 60 is half. Okay, this is half. So if you do a bit cancellation, I can make TA the subject, and that will be what? TB 2 TB over √3. And that is like our equation 1. I'll go to the vertical axis, and summation of forces in the Y is 0. Please, I'm not saying summation of forces X equal to that. Obviously, I'll be putting semicolon here. It's like I'm applying that equation. Okay. So what we do here is we're going to sum all the forces upward equal to the sum forces down. You can also show one side minus the other one equal to 0, but I like to do balance it. I like to say this side is equal to that. So because these are cosine, cosine, the other side will be sine. And this are both going up. Yeah, they are going up towards this way, up, this way up. So up equal to 10G. So I'm going to get TA sine 30 RTB sine 60 is equal to 10G. Is equal to 10G. Okay, is equal to 10G. And then you can substitute what is sine 60 and sine 30 in it. So sine 30 is half, and TB sine 60 is √3 over 2 equal to 10G. You can use the 9.81, no problem. And this is, you can multiply everything by 2, so you can get like TA plus TB √3 equal to 20G. And that is equation 2. That's, I multiply everything by 2. So we can now substitute, so it's simultaneous equation. You can use calculator to do it, MATLAB, anything. Okay. But this is straightforward to use your head to do it. So let's do it. You can do elimination, substitution. Yeah, I'm going to do substitution here. So I'm going to sub them. There's, you, I think everybody understand this. 1 into, yeah. Everybody understand this. 1 into 2. And we have 1 into 2. We have 1 into 2. We have TA. So wherever I see T, I put that. So I'm going to get TA is TB over root 3 plus TB. Let me go man that diagram very and check. This was TA cosine 30, TA. Cosine 30 is root 3 over 2. Cosine 60 is half. Okay, cool. And that is TA is TB root 3 over 2. Or TB is equal to, even here I could have even used that. If like, let me use that. It doesn't matter. Let me just use that here to not do anything. TB is equal to half cancel half, so it's equal to TA root 3, equation 1. It doesn't matter. You could have used the other one, but it doesn't matter. So I can come here. In this case, if I do this, I'm doing substitution for TB. So this is TA. We keep the TA there, and then we add TB. TB is TA. Okay, let's go up. You see, it's TA root 3. TB is TA root 3. So this is TA root 3. And this is times another root 3 equal to 20G. Okay. So if you do it this way, root 3 times root 3 is 3. So this is 3TA, and this 1TA, so become 4TA equal to 20G. So nice numbers to work with. So TA is equal to 5G. Okay. And at this moment, of course, in Newtons, at this moment, you can use the calculator. Okay, you can use the calculator and do 5 times 9.81, which you could have done at the beginning, and this is about 49.05 newtons. And then you also work what is TB. So these are the tension, then you work TB. TB is just TA, which is 5G root 3. I like exact numbers, but if you want to use this on the calculator, it means you are multiplying your 49.05 by root 3, so times root 3. What do I get? Let me use my calculator here. That's like 84 points. Hold on, 84.95 something and so on newtons. Okay, so I don't know whether how this will allow me to do the next question, but maybe I'll do the next question in another video. So the first equation, question 1, I make TA the subject and I change it. You could have also made I also make TB. It doesn't matter which one you do, you get the same thing. Yeah, you just get the same thing. So it's a simple two unknowns. It means you are solving some kind of simple simultaneous equation, and it's so easy to do with your head. So we don't need maybe calculator or any tool like MATLAB or something to do it. You could just use your head to do it. Okay, and I believe I should stop here and record the next video, else that'll be too much to put in your WhatsApp. Okay, thanks. Bye.